All right. Okay, organic people, listening up. Ready? So, I want to show you what these reaction scheme questions look like. We also refer to these as being the flowchart questions, so just be mindful when you're looking online. It might be called one of those two things. But basically what you're looking at is a question like this, where they've left a lot of things blank, and they want you to figure out what all those various things are. So, some things to keep in mind with what we're looking at, I would suggest when you're working through this question is to annotate to make sure you know what things are doing, so that way you know what you should expect with your products and with your reagents. So something to keep in mind when we're looking at these sort of questions. Sure, I don't drop everything on the floor. Just getting my markers out. Okay. In order to answer this question, you need to have these guys memorized. And you don't need to have it memorized as in the whole flowchart, but you do need to have memorized what the different reagents do. That's why I put a Quizlet online with all the different flashcards to help you memorize the different reactions. Does that sound good so far? Right? So let's unpack this question. There's a lot of things I actually don't like about this question. This one is taken from the exam from last year. And when I first looked at it, I was like, is this a level 3 question? But in fact, it is a level 2 one. And there's some, like I said, there's some things I don't like about it. So first off, they said they have sodium hexanoate, which is shown below, is used to preserve foods, cosmetics, and medicines. My first issue with this, that was going to probably throw you guys off, is we haven't learned anything about this suffix and what that functional group is. This is, in fact, a level 3 molecule, which is why I am not happy they gave this question last year. But hexanoate is known as an ester. And we're talking about this functional group right here. Again, like I said, I don't like it because it is a level 3 molecule, but you can technically kind of get around it. It's not the end of the world if you don't recognize what that molecule is, but I think that's really unfair for you guys because you might already start panicking and be like, I don't remember learning about O8s, and that's fair, you haven't. But I don't want you guys to be overwhelmed when you see that. You can still answer the question without knowing what that is. Are we okay so far? Keep going? Okay. And also keep in mind, you have sodium over here, which is that guy over here. What we're basically trying to show with this molecule is that this is a carboxylic acid that has been neutralized. The way I know that is because I see C double bond O and then another O here. So when this was originally hexanoic acid, it would have had an OH. So I want to show you guys this nasty question because I don't like it. But just if in case you see something like this, it's just a carboxylic acid that has been neutralized. So remember, when we neutralize something, we take the hydrogen ions off of it. So we took the hydrogen off of that guy. So don't freak out if you see that. Okie doke? Okay. I personally like to go through and annotate the whole question first, and then backtrack to kind of think about, okay, what must I have in order to have the different reactions occurring? So first off, I see hex N2-ol. What type of functional group is that one? What's the OL ending mean? Alcohol. So I'm writing down that I have an alcohol here. Do I have a primary, secondary, or tertiary? Primary, secondary, or tertiary. So here's my OH. It's attached to this carbon. How many carbons is that one attached to? 2. So that makes it a secondary. All right, then I see concentrated sulfuric acid with heat. So again, this is what I mean by what I'm talking about with memorization. We need to know what that concentrated sulfuric acid does. So if you don't have your flashcards or your flow chart memorized, you're going to have to do that in order to answer these questions. If I didn't have this one memorized, I can start thinking about what I see product-wise. Do you see how there's two products here? So that suggests to me there must be major minor. Now, if I have an alcohol and then I'm ending up with a major minor, that tells me I must be having an alkene being produced. Do you see my thought process here? Should I backtrack? Backtrack? Okay. Do you see how there's two products here? So a major and a minor must be produced. So if I'm starting from an alcohol and now I'm going to a major minor, the one that does that, if I look at this guy here, is we go alcohols and we go concentrated sulfuric acid makes the alkenes. So I would expect these two to both be alkenes. And we know that that concentrated sulfuric acid is used to remove an OH and a hydrogen. So if I'm removing it, what type of reaction is it? Is it addition, elimination, or is it substitution? Good. So I already know reaction type number 1, this is elimination. Now, when I make major minor, we know we're taking this OH off and we're taking a neighboring hydrogen off, right? So it can be formed, the double bond between carbon 2 and 3 or 1 and 2. Do we agree with me on that? Yes? So I don't know which one's supposed to go for compound E and which one's supposed to go for compound F. Does that make sense? So I need to make sure I put the major and the minor in the right spot. So I actually need the rest of the question to figure that out. Does that make sense? So we have to look at the whole question to figure it out. Don't start filling things in. Look at the whole thing. So what I notice here is that I'm making my alcohols again. So we're forming alcohols again. And then if I look over here, this is my secondary one. And then that one's the primary. Can you see how it's on carbon number 1? So once again, we are using major minor because it's cheap products. Send that back in. This is why I say this is like a summary question because it's taking everything you've learned in organic chemistry and we're starting to put it all together now. That also double checks what we have out here. We have an alkene going into an alcohol. So is that elimination, addition, or substitution if I'm doing an alkene to an alcohol? Addition. So if I want to note what I have reaction here wise, we have an addition reaction. So if I'm doing elimination, we have Zaytev's rule and we have Markovnikov's rule. So the Markovnikov's rule states the rich get richer, and Zaytev's rule says the poor gets poorer. So which one am I using Zaytev's rule and which one am I using Markovnikov's rule? So with this reaction here, am I using Zaytev's or Markovnikov's? Zaytev's, because the poor is getting poorer. So this one here, we're using Zaytev's. I never can spell Zaytev's right. Spelled wrong. Oh, did I have it here? Maybe. Did I put it down here? Needs marks. Needs marks. So I just want to see if I wrote down Zaytev's rule somewhere so I don't have to look it up. I never can seem to spell it right. Zaytev's. And I think I can get Markovnikov. Let's see if I can spell Markovnikov correctly. All right, Zaitev's rule. And this one here is slightly different because we are adding to the molecule, so the rich get richer, so that's Markovnikov's rule. Markovnikov's rule. Are we okay with how I figured that out? Okay, now I can actually backtrack and figure out compound F. Do you see how this alcohol is on carbon number 2 and this alcohol is on carbon number 1? So that tells me that the double bond for compound F must be between carbon 1 and 2. Do you see how I figured that out? I see a confused face, so let me go back. Okay. Do you see how this alcohol is on carbon 1? Whereas this alcohol is on carbon number 2. So if these are my two options, when I add to my alkene, that tells me the alkene must be between carbon 1 and 2 for that to work out. So this tells me that this is 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So the double bond is between carbon 1 and 2. So if I was looking up here and I was taking the OH off and I took the hydrogen off of here, which is the rich carbon, in this case the rich has gotten poorer, so this is my minor product. And so on this side I should have my major product. So I have the same molecule except the double bonds between carbon 2 and 3. So that's how I figured out compound E and compound F. Yes, I know we have lots of colors going on. I'm trying to keep pink to being all my annotation colors and like orange to be the type of reaction, and then yellow to just know when you're using Zaitev's and Markovnikov's, and then products or chemicals, organic chemicals, I'm putting in green, and then I'll put another color for the reagents. Nice little pop-up. Does this guy form geometric isomers? No, because it has the 2 hydrogens. Does this guy form geometric isomers? Yes. See what I'm saying? The flow chart is basically a summary of everything we've learned. All right. Are we okay with that so far? All right, if we were looking at this guy here and we're adding the OH, so the rich gets richer. So is this the major or the minor product that's formed? The rich getting richer. That's the major because you see how the hydrogen on the end, sorry, the carbon on the end has more hydrogen, so it's gained another one. So this is my major. And then this one would be my minor. Remember, major just means it's formed in a higher quantity. Cool. All right. Awesome. So now we have to figure out this last section of our flow chart, plus we need to make sure we note in all our reagents. So what I see here is a salt from a neutralization reaction. And if I was to backtrack to this, now we are thinking about the 2 intercepting kind of areas. So I see here that this is a salt from a neutralization reaction. In this case, we're thinking about a carboxylic acid. So compound G must be a carboxylic acid. which makes sense because I have a primary alcohol here. So if I have a primary alcohol going to carboxylic acid, I need to think about what reagent I need and also what type of reaction I need. So this is one of the reactions I haven't listed, but if you guys remember, if I'm going from an alcohol to a carboxylic acid, you guys remember what we called that? Starts with an O. That one's oxidation. This is why we got to memorize our flowchart. So alcohols to carboxylic acids, that's an oxidation reaction. And again, now we can start filling in what we need reagent-wise. You guys did that as part of your identification tests. So type of reaction for this guy, this is an oxidation reaction. This one here, type of reaction, that's a neutralization. So what I have forming here is a carboxylic acid. So what I've changed is I have this exact molecule here, except I removed the Na and I put the hydrogen back to it. So that one is CH3, CH2, that's 3, 4, 5, 6. So that is my carboxylic acid there. C double bond O with an OH. And then when it gets neutralized, we take the hydrogen off of it. Now let's fill in our reagents. All right, so this here is a neutralization reaction, so I need a base. The base that I'm using in particular is sodium hydroxide because I see sodium is the cation that was attached to it. So this reagent here is NaOH. In order to do an oxidation reaction, I need some sort of oxidant. So we have lots of choices. You can use permanganate or you can use dichromate. Either one is going to be correct. Just make sure you have heat and it is acidified. So there's two choices, the permanganate or the dichromate. Both of those work. So hydrogen, let's do the permanganate, MnO4 with heat. You could also use, like I said, dichromate. And the last reagent I need is how do I go from an alkene to an alcohol? So alkene to alcohol, we need dilute acid. H plus H2O works, and you do need heat for that one. Make sure you note if you needed a reagent with it, like if you need a catalyst, do you need UV light, do you need heat? All those things will be extra detail that you need if you're trying to aim for that excellence bit. And that's how you fill in a flowchart. It's basically a summary of all organic chemistry. So basically everything we've learned gets summarized in one of these guys. Now, obviously, when you're answering the question, you don't need to put down all the annotations that I did in pink. That was just me showing you how to process the question. It can be very intimidating when you first look at it, and this is why I'm saying I find in general organic is easier to get an excellence on, but harder to get the achieved on. Because if you can fill in this, it's an easy excellence point. If you can't fill this in, it's really hard to get started. So just take your best guess. There's usually points for your guessing. And I'll show you guys the marking schedule as well. And that's everything I have to teach you for organic. All the external. Questions, concerns, or comments? Don't worry, I will scan this and I am recording it. And trust me, you guys are going to have a huge head start with level 3 chemistry because you've done this. Because the only difference between this and level 3 is that we give you an extra couple new molecules. Same sort of setup. Flow chart, identification tests, that sort of stuff. All right, let's find the answers, which I hopefully put on Google Class or it's at Google site, but I may have forgotten because I was trying to very quickly make this. This, can you? What? Oh, did I not give you one? Thank you. Yeah. All right, this was question number 2. Where's question 2? Question 3. So question 2, you see how they've given a list? So they say compound E, compound F, compound G, reagent 1, reagent 2, reagent 3, type of reaction number 1, type of reaction number 2, type of reaction number 3. So I only gave you the first part of A. I didn't give you any of this justification stuff because it was more or less the same you guys have seen. Now, here's what I'm saying. 3 out of 9 correct is an achieved point. Again, it's really kind of, I think, challenging to get this to an achieve because you gotta have to know everything to kind of answer it. Worst case scenario, take a guess. So like, for example, there's 1, 2, 3 different types of reaction questions. So you take a guess on those 3 and you got those 3 right, you can get an achieve point. So take a guess on everything. Same thing with theory reagents. Take a guess, take a guess, take a guess. Even if you don't know what's going on, because you only need to get 3 correct in order to get the achieved. For the merit, that one was getting 5 out of 9 correct. And then for the excellence, it was 8 out of 9 correct. From my experience, though, people either know what they're doing or they don't know what they're doing. So people generally only get excellence and then not achieved. So, but it should hopefully be an easy excellence point if you have all those reactions memorized. So, because it's not, there's no explanation to this. The processing is where the excellence is coming up. So if you see, that's what I'm saying. All this processing here, all this thinking about what's going on, that is helping me get to the excellence level thinking. Okay? So make sure you memorize those reactions. So that's why I've linked, again, that on Google Classroom, sorry, on my Google site. There's that Quizlet that you can do. And it has the reactions both for the identification test and the reaction scheme. So for example, you can flip through it and go, okay, what is the color change for acephate dichromate? So you can make sure you memorize what that is. It should be an orange color to a green color. And if you go through the slides, there will be other things like, okay, let's, don't want to sign in. Let me just refresh that page. You guys can sign in. These are all reagent questions. Yeah, so here, reagent needs to convert an alkene to an alkane. That's hydrogen gas with heated nickel or platinum. Okay? So really useful for you guys to use that. And then there is like games you can play with this as well, because there's like tests, there's match. And then I'm happy to host this as a Quizlet Live if you guys want to play it as a class to help memorize it all. But there's basically 25 flashcards. And it also goes through the type of reactions as well. So like make sure you know what addition is, elimination, substitution. Cool, that is us.